Juhi, Akshat is here. Huh?
Okay,
He's
perfect.
joining in any minute around.
Done, done. Hi, welcome, sir.
Hi everyone.
Hello, Akshat sir. Rushabh here.
Hi Rishabh, how are you?
I'm doing good. How are you, sir?
I'm also good. Yeah.
Hi, sir. I'm Juhi. I'll be the host for this afternoon. If you have any or need anything during the presentations, you can let any of us know that.
Definitely, thanks.
and our esteemed judges and our enthusiastic participants. Welcome to Cypher 3.0. We're truly honored to have you all here today. I'm Juhi Prohit. I'll be one of your hosts this afternoon. We want to make it known that we greatly appreciate your commitment throughout the entire 18-hour coding marathon. This event caters to the creative and curious like you. It is your passion that fuels our event and leads it to greater heights. We hope that you all have had as much of a memorable experience as we had creating this for you. Now, let us get to know a bit more about our judges today. Our first judge, Mr. Akshat Priyesh, is a seasoned data scientist with over 7 years in BI, ML, and AI. Currently at Boss, he spearheads impactful projects, encourages collaborations, and shares global insights. His passion lies in architecting top tier solutions for diverse challenges within the realm of data science. Let's welcome him to the panel.
Thanks, Joey. Thank you.
Thank you, sir, for your time. Our next judge, Mr. Saurabh Srivastav, is the AI luminary at Geo Platforms and leads groundbreaking work in generative models. With a PhD in computer engineering, he optimizes YOLO for unmatched accuracy, delivering seamless user experiences across industries. His expertise in computer vision and deep learning is reshaping the tech landscape. Let us all extend a warm welcome to him on the panel as well. Thank you, sir. So before starting, here's a reminder of the problem statement. Aryan is the owner of a family-owned grocery store located in Mumbai. He grew up in an underprivileged background and he remembers vividly the struggles that his family store faced due to poor inventory management and untimely food orders. These issues led to a deadline in business and ultimately poverty. He approached Fetch AI to help him out with his grocery store issues, develop a solution that utilizes the UA agents of Fetch AI, and create a deep learning model to help save his business. To all the talented participants, thank you for your dedication and hard work in preparing your projects. Now is the moment to shine and showcase your creations. Without further ado, let's commence with the presentations. Best of luck to all the participants. So let us start with the first one, Team 121. Are you all here? One second, guys. Okay, no worries. We have the next team here, team 140. Samar and Vitrak, are you all here?
Yeah, we are here.
Okay, perfect. So y'all can go ahead with your presentation.
Oh, sure. Yeah.
You'll have 10 minutes. All the best.
Thank you. Okay, I'll start. Good afternoon, Mr. Akshat and Mr. Saurabh. So I'm here with my team, Marshmallows, using Fetch AI and Power BI plus deep learning. So we have created a model plus a dashboard regarding the problem statement. So I have a teammate, Vitrag Khataria and Tristan Hancock. I request Tristan Hancock to go ahead with Fetch AI. Tristan?
I'm sorry, Tristan isn't here yet because he hasn't been added to the room. I'm just
Oh,
contacting him.
okay,
Just a minute.
cool. Hi, Joey, can you add Tristan?
Okay, is he in the waiting room?
Yeah, he's saying he's in waiting room.
Okay, 1 second.
Yeah.
You have told them to let them in. Just give us a moment.
Sure.
Yeah, he's here.
Yeah.
Hello.
Hi, Tristan. I just introduced myself, and you are
Yes.
okay to go forward with Fetch AI.
All right.
Yep.
Right. So I'll introduce myself then.
Yeah, I did introduce yourself. You can
All
just
right.
go forward with Fetch AI. Yeah.
All right. So good afternoon, judges. My name is Tristan, and I will be presenting our agents and how we have implemented Fetch AI's agents in order to solve Aryan's, business problems. Now, Aryan is not the best as business, as stated in the problem question. He has two major issues. One is the inventory management, and the second being untimely orders. Now, we have devised our agents such that we have a main agent named Marshmallow. Marshmallow speaks to our remaining three agents. Zach, Alan, and Rob. Now, what Alan will be doing is Alan is going to be managing his inventory entirely. It will allow, I will demonstrate to you completely what we can and what we can't do with Alan. And Alan is going to be taking care of our inventory completely. Zach is going to be managing how our time works and when we can set working hours in order to prevent untimely orders. And Rob is where our deep learning comes in, where Aryan will be able to understand how his business is performing, where his sales will be, how his sales are so far, etc. Now I will be sharing my screen. If I could just uh yeah, is my screen visible?
Yeah, it's visible. Tristan.
All right. Now, before continuing with our project, I'd like to be very honest. We had a lot of challenges and difficulties while trying to connect the agents to one another, which is why, as of now, I will only be presenting its individual working of the agents, and there's no connection between the agents during this presentation. It's a bit unfortunate, but there were a lot of issues that we had that we overcame. Unfortunately, due to time, being a hackathon, we were unable to complete it entirely. So starting with our marshmallow, which is our main, I'm going to devise it into 4 different terminals where we will run it and check what's going on. So if I just run my marshmallow, we fetched our address. The address is very important in order for them to communicate. Now, what essentially happens here is that Aryan is now going to see a few options. He's going to be able to check his inventory, check and change timing and his statistics. Now, since these, if I run it right here, you will see that there is an error that will be thrown. Right now, I'm having a socket error. I'm not sure why it was working a few minutes earlier. I think I have to refresh it. But yes, this is where it will go into our inventory. Now, coming to our inventory, I will be running Zach, and we can see how Alan is helping us with our issue. So Alan is going to give us a few options here. He's going to allow us to display our optimized stock. He's going to allow us to display an ABC analysis. What an ABC analysis essentially does is it checks our data set. It's going to rank according to the sales of how well they are doing. Now, if a sale is doing really well, what's going to happen is it's going to mark it as A. If it's doing all right, it's going to be B. And if it is doing really bad, it's going to be C. Essentially, what this is doing is it's allowing Alan to understand what items need to be restocked more, what items should not be as important, and how much is left in his inventory. Now, if I run this right here, there's an error thrown here, but if we go up over here, you will clearly see that we are getting all of his quantity and stock and everything that's added over here. Now, due to an issue, I cannot add or remove it for now, which is a bit unfortunate. So I will go to the next step. So we'll check the ABC analysis. And as you can see, it is giving us a very clear indicator of what should be sold and what should not be sold. So if you see here, each of my items are graded with B, A, C, A, and you can clearly see which items should be restocked the most. This gives Aryan a very clear insight of what is working in his business and what is not working in his business. So if you see here, Aryan, your best products are, it mentions your cakes, chicken, eggs, fish. So all of these are A ratings, which gives Aryan a good insight into his business and how it's performing. Heading to our last part, that is Rob. Now, the way we combat untimely orders is that we want to set how many hours the business is essentially running for. If you have a grocery shop, I want Aryan to be able to essentially select how many hours he wants to work. So I'm going to set in his working hours start time. I'm going to keep the start time as 8 a.m. Now that his business is starting at 8 a.m., it will only run till I put in a certain number, which in this case I wanted to run from 8 to 11. Now, if you can see here, we can now check the working hours that his business will run. So now if a customer would like to actually order something, it will first have to check through the select working hours. If when it is putting a request in the select working hours, then only will they be able to place an order. This is a huge way we can combat untimely orders and also prevent a lot of issues that he might face with his business. Uh, that is mainly done from my part. For Zach, I'd like to get into the deep learning module, which I believe Samarth will be presenting.
Yeah.
He will be explaining how we have used deep learning and integrated it into our project.
Okay. I'll just share my screen.
Yeah.
Share screen. Is the screen visible?
Not yet.
Ah. Hold on. I just joined.
Also, just a heads up, guys, you'll have 2 minutes remaining. So,
Okay.
yeah.
Juhi, can you please add Samarth back in the meeting?
Okay, 1 second. He's renamed with your team number, right?
Yeah, Samarth Borade, Marshmallow.
Chewy, I'm letting him in. I'm going to the main room and letting Samarth in.
Also, guys, if any of y'all cannot like share, just have that someone else can, share it because you'll be wasting time like that.
Yeah, understood. He's probably here already. Just drag him into the room, please.
Oh, sorry for the delay. Yeah.
Yes, sir.
Sorry. I'll just share. Is it visible now? I hope it's visible.
Yeah, it is.
Okay. Hold on. Yeah, I'll just start by sharing the screen. Yeah. So we have applied a deep learning model on a data set known as process to data, which we found on Kaggle. And first, we started by applying EDA. After applying EDA, we have applied a few operations, and we are making a predictions data set based on categories and subcategories and also sales. Coming up, we have used a deep learning model, a simple feed forward deep learning model, a network using linear activation function as the output layer for regression, and at the end it will just give out a CSV file known as prediction.csv. Now I'll show where and how it will work. So we have made a dashboard. Yeah, is it visible?
Yeah.
Okay, yeah. So this dashboard will help Aryan to just check and analyze all the orders and all the categories and all the profits he has made per categories. So if he wants to check by cities, it's loading. He will get all the data as per the cities. Coming up next, he can also see the profits by category here. Next, we have analysis by city and region. If he clicks a region, he can just see which region is doing well. He can even sort it here. Going also to the city, which city is doing the most highest sales. Next up, we have is the inventory. Yeah. Like Tristan rightly said, inventory management. The inventory data set here also can be used. So for here, I've taken example for beverages. If you see the stock current of beverage, we have 681. And if it falls below 500, it will just strike a message that it is below stock price, below the stock, my bad. Yeah. Coming up next, we have the percentage change. This will also help him to see the trends between the 2 months. So here I've selected 2 months, March, April, for the year of 2016. And yeah, so it will just show which categories is performing between the 2 months well. If we see here, bakery is performing well in March, and it also shows the percentage in profit that it is showing it as a loss. If we just see the numbers here. Coming up next, we have a prediction page. This page uses the prediction.csv output that we got from the deep learning model. If we see here, this predicts the future data of the next 2 years, 2019 and 2020. So it will show how it will perform in February, and it will also be helpful for him to check by categories and subcategories. Um, yeah, that was it. Vitrag, I would like you to conclude.
Yeah, am I audible?
Yeah, you are.
So, coming on to the future scope for this project. So, the first thing we would like to implement in the future would be real-time pricing model. By implementing a real-time pricing model that can adapt to changing market conditions and demand fluctuations and user behavior, that would utilize machine learning to analyze real-time data. Then, coming on to the user behavior analysis, by using machine learning techniques, we can
Yeah.
analyze the uh, user behavior data, considering factors such as purchase history, preferences, and sensitivity to price changes by each and every individual customers. And so that would be a personalized recommendation system as well. Lastly, the dynamic discounting, explore the implementation of dynamic discounting strategies in addition to the pricing adjustments. Lastly, the second future scope which we would like to work on was with the time series analysis, advanced time series and techniques considering change in the weather. So the we would recommend products based on the change in weathers. For example, if the weather is cold, we would recommend Aryan to stock up more on hot chocolate and go low on the inventory of ice cream. A simple example. So that is a seasonality adjustment. Then the anomaly detection. To identify unusual patterns or events that may impact the sales, which are not part of the regular trends. And lastly, under time series forecasting, predictive analytics, extend the time series analytics to include predictive analytics along the identification of potential future trends and insights. To conclude, these future scopes considerations aim to enhance the accuracy of time series analysis and implement uh, cutting edge dynamic pricing strategies, positioning the grocery store for increased competitiveness and adaptability in the market.
Thank you, judges.
Thank you.
That was a wonderful presentation. Thank you, guys. Judges, do you all have anything to say?
Yeah, you could have used RNN instead of ANN. Means you have not considered seasonality, right? In
Yeah.
conclusion, you told that you will be considering this thing like LSTM's RNN, but actually you missed in the ABC analysis, right? So you are not considering any time related data or not. You are tracking that. So why it is? Means why did you did like that? Thought of doing like that? So if you can.
So actually, we were also new to deep learning models. So the first thing we thought of, like, we need to find the future profits. So it was prediction model. So we thought of going for ML, but we were told to use DL. So that's why we use a simple feed forward, which we knew, and at the end we use a simple linear activation function. We could have used LSTM. That's also a good thing.
But do you feel that it is
Yeah.
a regression problem?
Yeah.
So yeah, it's good solution.
Yeah.
I would like to add on to the point, as I said about the seasonality adaptability as the future scope. LSTM would work for such a kind of problem statement. So in the data set which we fetch through Kaggle, so it has some of the attributes such as the postal code of the customer where he is ordering from and the time as well. So by using weather API also we could fetch the seasonality and we could implement in the deep learning entire neural network.
Okay.
Yep.
Yeah, so Team Samarth, your solution is very good. And I want to know some out of box from this angle. Suppose you want to use like Chat GPT, like you are these tables are there, na? There are bakery stores. How many bakery stores are like that?
Yeah. Mm-hmm.
So what do you think about it? It is possible to solve this problem through some generative AI model or some chat GPT type of thing. So first, I want to know, this the chat GPT and generative AI like that.
Yeah.
Or
Obviously, we do know ChatGPT. We can use the OpenAI API for such.
good.
If we are using that, we can just use that to train our models also.
Hmm.
Uh, as far I know, GPT-4 also has, we can upload our CSV files there, and
Correct.
we just completely give a trained model, including what to analyze, what to not, future predictions.
Yeah. Yeah. So if any other approach means without using open AI, because if you are using any API, so
Mhm.
your data will be easily transferred from your system to this another
Yeah.
server. So what do you think about some this security point of view? If you are not using any API or now how you can develop this same thing without using any API?
I'm not sure, but I think the main purpose of Fetch AI agents would be this thing. It is focused in decentralization. I think that focus on security part, having a
Okay.
complete transparency, and I think that answers my question.
Yeah, good knowledge. Yeah,
The agents
thank you.
itself have an almanac contract that prevent any sort of discrepancies with our functioning software, which is why Fetch AI has really a big, I would say, a big revolution when it comes to implementing agents and then verifying it through a blockchain. It just has much tighter security and it's completely decentralized, which I feel honestly is much more safer to use than a regular, an API key than just stringing in. In fact, when we first started developing it, we were looking for an API key and we were figuring out how to do it until we realized that there is no such thing. You get an address of an agent and it just communicates between those addresses. And
Okay.
those addresses have to be verified in order for them to work. You cannot have an unverified or even a without the token that has to be, for the Almanic contract to generate. Without that itself, it won't work, which again adds to the security of using Fetch AI. We found it very interesting. We actually wish we had more time to make something much bigger. 18
Sorry to
hours was,
interrupt, Tristan, again, but
yeah,
so we need to stop this because another team
understood,
is
understood.
waiting
Yes,
again.
thank you,
Yeah.
thank you. So sorry, thank you.
Yeah.
Thank you so much.
Thank you.
Thank you, guys. Very wonderful presentation. Next team coming up is Team 122. Team 40, you can leave the room. Thank you. I'm so sorry, judges. We just had one thing. Each of the team would have 10 minutes, so like we can keep a track of all the 22 teams to be completed. I'll keep giving a reminder, but just keep the time.
Julie, Aryan is here, so yeah.
22. You can start with your presentation. All the best.
Yeah, thank you.
10 minutes. Keep that in mind.
Okay. So, hi everyone. I'll now start presenting. Uh, so our problem statement was around inventory management. So I'm from team 1 to 2 with team members and
Aryan, could you please stop for a minute? Akshit sir and Saurabh sir, have you updated your sheet of mark grading?
Yeah, I make my own, means which is mentioned in your
You
PDF.
haven't received the link for the rubrics or the judging part.
No, I didn't receive.
So I
But
will
I am
send it to you
making.
right now. I will
Okay,
send
okay,
it to you
please
right
send.
now. Please have a look on your mail IDs.
Sure.
Yeah, Aryan, you can continue, please. Thank you.
yeah. So my team members were Sasa Susmay Sahu, myself Aryan Sharma and Nitish Singla. So this was our problem statement in which Aryan, we were told that I am the owner of a family-owned grocery store, and my grocery store was facing problems related to inventory management and supply management issues. And we were supposed to develop a solution that utilizes U agents of Fetch AI and create a deep learning model to help save my business. So our attempt was to we used U agents to manage inventory and food orders, and we created some agents that monitored inventory levels, predict future demand, and automatically placed orders when inventory levels are low. Our solution also involves a deep learning model that can learn from past data and make accurate predictions and decisions. So this was the flowchart of our solution. First, we randomly generated a data set for my grocery store, and then we used a ML model which was based on Euler state networks, which is used for time series data. And we created three models. First was to predict when to stock up for inventory. Second one was to predict the demand and supply based on data, and third one was to predict the optimal amount of products to buy for the inventory. And we also made some three agent categories for inventory management, for demand forecasting, and for order management. And I can see that the pictures here are not clearer, but further in the presentation these points are discussed for all the three agents. So first, let me talk about our ML model. It is based on Euler state networks. It is a novel type of reservoir computing model, which is based on the numerical solution of ODEs. And the EUSN model uses forward Euler discretization and antisymmetric recurrent matrices sorry, to design reservoir dynamics that are both stable and non-dissipative by construction. In simpler words, it can be visualized as a RNN, but it's a modern form of it. It is based on the concept of RNN, but it has some other concepts also. So the we have as we have I have told that we have used three models to predict when to stock up for inventory, demand and supply based on data, and for optimal amount of products to buy for the inventory. So we have three agent categories. For inventory management agent category, we have used several agents for inventory analysis and tracking, purchasing and replenishing, inventory classification, forecasting, dynamic inventory replenishment, and reporting. So this is the detailed view of all the agents. In inventory analysis and tracking, our agent performs daily inventory analysis to identify and resolve discrepancies and problems. It tracks inventory flow to predict future needs. And for purchasing and replenishing, our agent determines when and how much to stock to order. It uses technique like EOQ, which is economic order quantity, and MOQ, minimum order quantity, to decide the optimal quantity to order, balancing the cost of ordering and holding inventory. For inventory classification, our agent uses techniques like ABC analysis to classify inventory based on its importance or value. This helps in prioritize the management of different items and optimize the use of resources. For forecasting, our agent uses historical sales data, market trends, and other relevant information to forecast future demand. This helps us in planning for future inventory needs and avoiding stockouts or overstocking. For dynamic inventory replenishment, our agent uses AI-driven strategies, which was discussed earlier, like our ML model for island state networks, to dynamically replenish inventory. These strategies use machine learning algorithms to detect patterns in sales data and make accurate predictions about future demand. And for reporting, detailed reports on inventory operations is created in like ad hoc reports like Excel or Word. And these reports provide valuable insights into the inventory situation and can help in decision making. For simulations, our agent uses simulation to assess the performance of inventory systems. This involves measuring key service values, stockouts, and fill rates to evaluate the effectiveness of the inventory management strategies. So, in summary, inventory management agent category has several agents. I think there are 7 agents, and which perform individual functions, which help us to optimize our inventory management. And for the order management agents, there are order processing agent, order tracking and updating, order prioritization and matching, communication management, reporting, troubleshooting and enhancement, logistic management, and KPI tracking. For order processing, this agent is responsible for all aspects of order processing, from entering new orders to inspecting shipments. This includes verifying the availability of placed orders and ensuring that ensuring their quality before shipment to avoid complaints and issues. For order tracking and updating, this agent tracks and updates customers' account information in the database, including payment, posting, and order verification. It also ensures smooth and timely freight process flow and accurate and timely data entry into the operating system. For order prioritization, the agent manages and prioritizes orders, matching inventory to orders. This involves ensuring an appropriate order flow with compliance to organizational policies, which will be defined by the organization. For communication management, it communicates with the sales department and customers department, handling
Just a
customers.
heads up, I'm so sorry. You'll have 3 minutes remaining.
Okay, I'm just wrapping up. And for reporting, mentioned in the inventory management, the same agent is used here. And for troubleshooting and enhancement, the agent is responsible for troubleshooting in purchase process, deriving possibilities for enhancement. It cooperates with the finance department to resolve the pricing issues. For logistic management, handles business processes that occur before the stock arrives at a warehouse, generates paperless invoices and purchase orders. For KPI tracking, if we have used relevant KPIs like no in a user-defined dashboard that display real-time data. This includes managing order promising activities, including the scheduling and rescheduling of the order fulfillment lines and reviewing data related to promising fulfillment. And for the demand forecasting agents, here is the main use of our ML model. I'll just skip to the main part. We have first done the data collection, and for data analysis, this agent analyzes the collected data to identify patterns and trends. And these patterns and trends are then given to the machine learning model, which accepts time series data. And for forecasting, based on that data analysis, the forecasting is done by the island state networks. And for evaluation, this agent evaluates the accuracy of forecast, including various metrics and techniques like accuracy score, F1 score, etc. This helps in accessing the performance of the forecasting model. And reporting is done in the same way in the previous models. And we have also included continuous learning agent, which automatically access the new data and runs the model on them. So this was our solution to the problem. So in short, we have used island state networks as our machine learning model, and we have included several agents in the 3 broad categories for optimizing the inventory management and supply management. Thank you.
That was a great presentation. So do you all have anything to say?
Yeah, did you implemented this as well? All the loops that you have mentioned here?
Yeah. We have implemented Isla state networks and we have implemented all the agents.
You can give a brief in a minute, so it will be good.
Yeah, I can share my screen. No, wait, I have to open it. Just a second. I'll share my screen now. My screen is visible, I think. Oh, sorry.
Yes, it is.
But it's the wrong desktop, I think. I'll share my screen again.
Okay.
Promesify system code USN time series Discord Google Chrome ML. I can't find like I can I share like
That's okay. That's okay. No.
I have shared my zip file. If you guys can please check that out. The all the code files are written in the directory structure of three broad categories: inventory management, that are .py files for all the agents, and the ILA state network code is implemented as a class. So we have imported in the all the agents wherever the ML model is required. I'm so sorry. My Zoom is open on another desktop and that code
Okay,
is
that's fine. That's fine. Okay.
yeah.
Yeah, Aryan, it is a good solution. Only one question from my side. How this ML solution you can connect with this dashboard
Yeah.
to which API?
So for KPIs, we will use there are many like we have seen that for KPIs, it is a basic score and there are various APIs available publicly which we can use to update that on the dashboard using our ML model outputs. But I think there should be we haven't developed that link between the ML model outputs and the KPI right now because like we have a time crunch, but yeah, it can be developed. We will divide our model outputs into various classes and that will be used to calculate the KPI, which
Okay,
will
Aryan. Yeah.
be further
Thank you.
showed on the dashboard.
Thank you.
Thank you, Arjun. Next coming up, we have team 123. I'll just let them in. If y'all have anything to say, so you can let me know. I'm just letting the other team in.
Yeah, just you can tell them not to explain the problem statement again. So it will be
Okay, done. I'll let them know. This is coming in. So sorry. Okay.
Hello.
Are you there? Yeah, perfect. You have
Yeah.
10 minutes for your presentation. You can start. All the best.
Thank you. One sec.
Yeah.
I have not. You'll have to pin my video because ArcLinux doesn't support screen sharing right now. So if you can see my screen right now, I think I'll start. Okay, the main problem for Aryan we saw in the problem statement was.
I'm so sorry to interrupt you, Varun.
Yeah.
So the process of inform, you don't need to explain the problem statement. Come directly to your solution.
Okay.
Yeah.
So we made a model using forest regression randomized. It basically has three different CSV files, the main sales files, which has the main transaction ID, the timestamp of its sale, the product ID, and the category. For example, it's a fruit, vegetable, grocery, or something like that. The price is the price, the amount of quantity per sale, and the total bill finally. The sensor storage temperature basically tells you what the temperature of a specific item was. For example, if it's milk, it's supposed to be at a colder temperature. So obviously not all items in the grocery store has a temperature. So some of them do, which we have put in our data set. Now the stock levels basically tell them how much stock is there in the grocery store currently. And the estimated stock will give you is the final result, which will give you the average mean value. I'll just showcase the thing now directly. So this is the main website. We've built it using Django and just Django. This is the main inventory list. We have inputted all our data set. On the home page, he can see what all vegetables are there, what stocks are there for each specific order. You can make a new purchase in case needed from the supplier, whoever is supplying him, or you can make a sale in the sale order. We made a sample sale. You can see it here. It shows you everything, whoever bought it, what did they buy, how many quantities. These are all random values for now. For our coding part. Okay, so one sec. Yeah. Yeah. So for this is the visualization Jupyter file which we have made. As you can see here, on our CSV file, which I'll just show you. Edit CSV. Yeah. So each CSV file has more than 4 or 5 columns with transaction ID, category, the price, the quantity, and the total bill, and the timestamp, obviously. Now here we can see the quantity by category. So for example, the baby products sold in that duration of time was around 400. In the next chart, we show you the amount bought by a single person in one single transaction. Obviously, the inflated numbers, we have not actually seen a number. Now, the transaction by a specific category. For example, baked goods, they were sold by 453 total. And the most, as you can see, were spices and herbs. Fruit was the next. And then there's packaged foods. Now here you can see the unit price versus the actual value of the bill, what they sold. The main, these are all calculations which we have done for the main RME and MES value. Okay, so for example, here you can see the RMSE value which we print is basically it's the difference between the predicted stock levels by our trained model over here, which we've trained it 10 times on a random forest regression model. And it is the difference between the predicted stock and the actual stock. So whenever it's a lower number, it means it's running better, but there's a better accuracy on it. Now the mean absolute error is basically the error check. Basically, if it's lower, obviously it's performing better. So there's less average deviation between them. Now, yeah, this is the training part. I'll just remove. Yeah, this is the part where we trained our trained model over here, as you can see here. It had average mean value of 0.2. We have 10 folds over here. It was trained on this data right here. This is all random data which we've made randomly. It's not an actual data set. The Django files are here, which we've provided. It has the main, as you can see, one sec. Windows 4. It has the home page where you can see everything. You can directly make incoming stocks. You can directly make outgoing stock, and then you can handle directly over there. Now for the UAgents part, we have made very basic. So with the MAE values, we can check if the order is low, if the stock supply is low. So obviously if it's low, it will directly start ordering from our suppliers, we have yet to implement this function over here inside the main Django file. But the agent part is complete. Basically, what it does is if the stock is low, it will directly order a supplier and send a message in the print file that has ordered this much for this much value. That's basically it for our presentation.
That's good. So coming to your data set that
Yeah.
you have generated, it's synthetic data set. So how you handled oversampling and undersampling here? So
We have cleaned the data set a bit. It's not fully clean. For example, if you can see in our, one sec. Yeah. For example, over here,
and also tell me how you identified the features on which you are going to train your model.
as in, like
Uh,
which random
how
forest
you
regression.
found the correlation? Yes, that's what.
Yeah, so random forest regression will be the most stable over here because it will combine predictions of multiple trees, and thus it will have a very stable prediction value. So even though each tree will have high variance, when we compile them on in parallel, it will have a very low variance between each of the separate ones. So I thought the random forest regression was pretty good for our
Okay.
build. Here, as you can see, after importing everything, we have checked if there's anything null values in our what's it called, in our CSV file. So we checked if there's any null values.
No, actually you are getting wrong. So in the way I was asking that
Yeah.
oversampling, what is the distribution of data set that you have generated? Means it has actual representation of all the classes. That's what I was asking.
Okay, so I'll show one sec. The main data set we got was from this Kaggle website, and we
Okay.
have taken I'll just show the website. I'll find it on my Discord link. One sec.
That's fine. That's fine. That I understood. Anything that you are doing to generate the data set, that's what I was asking.
Yeah, the entire data set is not of this because this data set had a lot of other things like low fat content. So
Okay.
we've cleaned most of that part, and we've added some stuff like transaction ID tracking. So the RM can see what he wants to track, which specific order he wants. We've categorized everything in a fruit pile or a grocery pile, as you can see here. Everything is categorized in an item fat content style instead of uh
Okay, that's nice. And how you use the timestamp that you had in your data set
yeah.
that you
So timestamp basically tells us how quickly the stock is running out. So in case the stock is running out quickly, we need to quickly uh restock it. Where's the ah,
Okay, for example, in summers cold drink sales will be higher, right? But
yes.
in winter it will be low. How you will handle
We
it?
haven't done seasonal changes for now. We've only done yearly changes. So
Okay.
grocery items will be uh,
Okay.
ordered during summertime mostly, depending on which
Okay.
grocery it is.
Okay, fine. Good enough.
Yeah, Varun, so it is a great presentation and your approach is also very good. I want to know if why are you using this machine learning technique on this solution? Might be it is capable for this SQL also. What is your
So
opinion on it?
I mean, we're using SQLite for storing everything, obviously, but I think using a machine learning model, for example, our model over here, it will be
Mhm.
much quicker to do that instead of just having a lot of databases open. It will be much faster to load the website as well. So all the network will happen in the background, and we just have to load the database. For example, I'll open the admin site here.
Yeah, correct. And
We can quickly change everything here instead of going to each database and checking it.
and for nowadays, suppose there are pandas.ai, you heard about it,
Yes,
pandas.ai.
yeah.
So did you use here in pandas.ai for prediction?
We haven't used we have used well, I'll show you right here. So we have used sklearn because it has the direct random forest regression model. So we imported that and just did it directly from there instead of using pandas. And
Yeah, but the problem statement has clearly mentioned that you need to use neural network deep learning loops.
yeah, sklearn is a deep learning method. Random forest is a deep learning network
Uh,
which uses.
okay, fine.
And one more thing I want to ask is suppose you said that this SQLite is also can use like here for storing the data.
Yeah.
So did you know about this semantic search vector restore data sets database like that?
Semantic search vectors.
Uh,
Uh, I have no idea about that.
okay. So okay, I am good. Yeah. Thank you.
Okay.
Arun. Yeah.
Thank you.
Thank you, Arun. That was a lovely presentation. Next, we have team 124. 1 second. We have the next team coming, so 2 minutes. The next team is just coming in, sir. And if you'll need any breaks or like a time now, please let us know.
So Joey, how many teams are left?
We have about 18 teams left, sir.
Okay.
Yeah. That's what I'll keep giving them a reminder so that we actually do finish it in 10 minutes slot. Hi,
Am I audible?
Yeah, you're audible. Are your team members coming or you're the only one?
Actually, ma'am, they are busy attending an event outside, so it's difficult for them. So it's decided that I will present instead of them. Are you fine with it?
Yeah, that's all okay. Okay, you have 10 minutes. You can start with your presentation now. All the best.
Okay, ma'am. Is it necessary to enable my camera?
That would be recommended, yes, if that's okay with you. or else no problem.
Actually, because I'm in PC, so I don't have a webcam enabled, but I have microphone, so it would be good if I could just use mic to present.
Uh, okay, but be sure that your solutions are shared.
Yes, I've just submitted and I will show the solutions. I'm sharing the screen.
Yeah, your presentation as well. Perfect. Your time starts
Yes,
now.
yes.
All the best.
Okay, so is it visible? Uh,
Yes, it is visible.
the presentation.
Not GitHub.
We files right now.
Actually, let me just adjust it. Okay, so now is the presentation visible?
Yes, yes, it is.
It's visible.
Yes.
Yes, you can go ahead.
Okay, so I'll just start with it. So I just enable slideshow. So can you see it?
Yeah.
Okay, so I'll start with. So actually, the proposed solution to the problem statement is an inventory and order management system by our team. So it's our team. We have three people. And to give a brief introduction, I'm from School of Engineering, JNU, Delhi, Jawaharlal Nehru University, and my teammates are from VIT Chennai. So actually, we three from the team. So now I will just present our solution. So basically, I have provided a general workflow of how it works. So what it does is utilizes TensorFlow to make a demand prediction model based on the data for the past 30 week sales. Basically, whenever we talk about machine learning, so we talk about features and labels, right? So what we did was we took the 30 weeks data, sales data, and took the first 29 weeks as featured and the last week as label. So we can work on a regression problem. I hope you can understand what I'm trying to say. So what we did, then after that we use the data to make predictions. It's similar to how we use text generation. We just take the data for the first 29 days and make a prediction for the next day. So what will we do? We will just identify the item with the highest demand first. And we have created five agents through Fetch AI, which was given in the program statement. So three agents are suppliers. One is negotiator and one is the main agent, which is order. So the order agent will take the data from the TensorFlow model, and as you can see the workflow, it will take the data from the TensorFlow model, and it will find out that for the next week which item would be the highest demand. Then it will go communicate with the negotiator agent through Fetch AI, and we have created a data set. So as you can see, the negotiator will negotiate with three suppliers. The three suppliers have different rates, so it will negotiate and place orders. The there are three supplier agents, and the supplier agents will communicate with the negotiator agents to place orders, and the order will be placed, and the communication will be through Fetch AI agents framework. So this is our workflows. Then I have then shown how our data set was generated. So actually this problem statement, we did not give well, we did not give a specific data set, right? So what we did was we generated our own. So basically you can call it a dummy data set or a simulated data set, but it's not completely dummy. So what we did was we took the big bazaar data set from Kaggle. So and the statement is of grocery store, so we filtered it. So remove some categories like home appliances and the electrical appliances to make it a grocery store suitable data set, and just cleaned it, and we added our values which we need for the model. So we added inventory values for the last 30 weeks and the dummy values of sales for the last 30 weeks, and we added supplier cost. So basically, so supplier cost will be always be low from the selling price. So we took a random value 0 to 15% and subtracted it from the selling price to make the supplier cost. And here is the example of the data set. Can you see it? Excuse me.
Yes, we can see. Go ahead.
You can see it, right? Okay, so basically this is the product names and the last 30 week sales, the inventory we generated. So this will be always greater because this is selling price, and this is the data set. So what we did was we took TensorFlow, as I explained, we used Keras, so we constructed a regression model for demand forecasting. So it was a 3-layer neural network. So it's a supervised learning, as I told, the first 29 weeks as features and the last week as labels, and a test rate of 20%. So here's the example code for the model. So actually, it's a dummy code. There are many things, other things like dropout layers and valid callbacks and the serving through API. But it's a hackathon, so it's a demonstration. So basically, what we did was made a simple model. So we took it and regression model, we set the optimizer loss and created the model. So now the final part is implementing it through Fetch AI. So these are our agents, negotiator. Basically, this is responsible for selecting the supplier, offering the product needed the most favorable price. So here's the order, which assesses the items that need to be stocked and initiates order with the supplier agents. The agents are communicating with each other. So these are some factors that we considered. So here is the screenshot of the output. So actually we hosted it locally, so we'll run all the clients on different terminals. So in Linux, this is the supplier agent 3. So actually this is the PPT and this was the code. Can you see it? Excuse me.
Yes, yes, we can see.
So this is actually the code. Then the first is a Jupyter notebook, which is basically filtering the data set. So we removed all of this. Actually, this is a training notebook. So this is our training notebook or defining the data set. We took it.
Did you thought of implementing LSTMs or GRU or any RNN?
Yes, actually, yes. I thought of implementing. Sorry, I thought of implementing LSTM GRU first, but actually, I have worked on a similar problem in text generation. Actually, so what we do is in text generation we also take LSTM and GRU. But I thought that this is like dummy model, so let's just make it simple because the main thing was to work on the fetch implementation. So it's like there are a lot of things LSTM use time series for these type of problems, and LSTM on top of that we can also include our bidirectional layers, embedding bidirectional embedding layers, and many other things. But we have decided to keep it as a simple demonstration for now. So
Okay.
we did this, and we created a dictionary which basically shows that what are the demand for the next week, and then using the dictionary we implemented our fetch AI framework. So
Just a reminder, we just have 2 minutes left. Yeah,
yeah, sure ma'am, sure, I'll just wrap it up fast.
yeah, sure.
So what we did was, this is an analysis, so we cleaned the data set. These are all the grocery items, and we generated our dummy data set. And finally these are our agents. So don't have much time, so I will just show the order placing agent. This is the U agents framework from fetch AI. These are our implementing our functions that we have defined in other files. So this is hosted locally. So that the seed. Well, it's running on Fetch AI, but it's hosted locally. So actually, that's we're using Fetch AI, but the computation is done on our own system. So these are addresses for the other agents, and these are all the functions which checks orders, the shows errors, the received orders, order status, and uses the other function from the to get this. And it also generates JSON files which contain the list of items need to be bought. So these are this baby skincare wipes. We also thought of implementing LLM, but LLM we only take as a last choice because of the resource consumption. So
So, which model are you thinking on LLM?
actually LLM, see, whenever we use LLM, we think about either OpenAI's API or Llama 2 if you want to run it locally, or Google Palm API. But I thought to quantize the model into 4-bit and run it on Google Colab for less resource consumption. So I thought that we could just interact with the dataset to LLM, like it will tell the five, give me just last inventory of this item, then it will LLM will use natural language to fetch, basically store the vector data in the vector database and generate a prompt using the similar data. If I you get what I mean. So, but we decided that we should keep it simple for now because in machine learning everything is about efficiency.
Yes,
And
correct. So in future, you can also think about this Google Tapas for
excuse
this.
me, excuse me, sir.
Google Tapas.
Okay, sir. That's the okay,
Yeah,
sir. I will look for it. Thank you for the information.
yeah.
So
Thank you.
this was our code. So thank you, judges, for. So if you permit, then am I time is up?
Yeah, good.
Okay, so can I leave now? If the time is up, then.
Thank you. That was a wonderful presentation.
Okay, so ma'am, thank you. And I'm sorry that I could not turn on my camera. Actually, I'm outside, so I will just leave now.
That's okay. Thank you. Okay. Next, we have Team 126. So they'll be just joining. So just a reminder, you all are updating the grading sheet, right?
Yes, we are.
Okay. Thank you so much. Okay, hi Advait. Are all your team members here?
Yes. Aditya and Aryan.
Perfect. So this is team 125. You all can start now. All the best. You'll have 10 minutes to go.
Thank you. Can you hear me?
Yeah, we can.
Hello. Oh yeah, okay. I'll just share my screen. Can you see it?
Yeah.
Yes.
Yeah, okay. So we are Team Dots, and our product is Invento GPT. So this is about revolutionizing grocery store management. I'll move on to the problem statement. It was creating an efficient inventory management system for grocery
Like
store owner using
you
deep
said,
learning.
the
And
judges have told you all don't need to explain the problem statement.
okay, yeah, okay.
Perfect.
So yeah, these are the tech stack which I have used. It was the interface is purely made of Streamlit. Libraries which I used are sklearn, CADBoost, MLX10, and U agents. And algorithms which I used were API algorithm. This is the overview of what we have decided to make in our product. The first solution that we are providing is the time series analysis. Second will be market basket analysis, and third will be fetch AI agents for a proper classification of the problem statement. So when you get on the page, this is a landing page. It also has authentication for in detail inventory stats. It will be accessed by every grocery owner or shop owner as he or she lands on our platform. Moving on, this is our first page, which is the demand forecasting analysis. I decided to go with Cat Boost because since I've deployed on Streamlit, it was very efficient and the processing time and parameter tuning takes much less than light BGM as I've noticed. So, sorry, I couldn't hear you.
Go ahead. Go ahead.
Okay, good. So yeah, it produces a line prediction graph for every item present in the data set for every store if there are multiple present. As you can see down, we can generate forecast for selecting store and selecting a item also. And above part shows the basic table which is present in the data set which we have been provided. Second will be the market basket analysis. In this, we have given the option of adding any kind of .csv file or any kind of Excel sheet which so a shop owner can provide us, and it will show the uploaded data. And as you can see here, it also shows the frequently brought together sections. So the top three sections which were brought together were bread, coffee, sugar, bread, tea, and Bonvita, and coffee, biscuits, and cornflakes. So it trains on any sheet, and it also finds the bundles which are often sold together. That is why we have put it in, and also it displays the rank wise in the bar plot chart. Third will be the detailed inventory algorithm analysis, wherein if a person wants to know in detail what kind of data is present, what kind of matches are we finding, especially the ones where lift or leverage is also found. So you can also find it out here. As you can see in the antecedent and consequent support, we can see the amount of decimal it is correlated to. Fourth will be the important thing, which is inventory manager agent and user agent. The important part was that to integrate it, we took certain parameters to make sure that the inventory which a person has shouldn't go surplus or also shouldn't be in shortage. So it sends immediate alerts as soon as a user or we could say an owner updates his or her own shop and checks whether if the inventory goes above a certain limit or below a certain limit, it immediately sends an alert to the user agent. So this is the kind of you can see. I'll also show you on the Streamlit which I have deployed. We can also see it on live here. But you can see the current quantity of sugar of 50, 65, and 80. It crossed the limit for wheat above the maximum limit 30, and cold drinks was above the maximum limit 40. And in the agent interface here, you can see that it was displayed. Yeah. So I'll show you the interface which I built. Just a sec. So yeah, this was the interface. It is also authenticated, so you can register as user email and it will successfully register as user. In demand forecasting, unfortunately, even after multiple iterations and stuff, Streamlit is quite delaying. So I'm not able to process it properly here. But in the frequently bought, we can browse the files here And if I just go, I'll just take, let me say. And for example, in the data, I have stored a grocery data set. It immediately shows what kind of data it present, what is the frequently bought section here, and also the empty, because all the data is in the first column, it shows the after columns also. And the data analytics section, you can also see the same data set being displayed to you in a proper way. And also the association properties here. And it also allows you to search and navigate through and also download a data set. Meanwhile, if you go to the main code, if let me just share the whole screen here. Yeah, I hope the screen is visible here. If I try to run the U agent here, yeah. So this will give me the current quantity of sugar. As you can see here, the maximum quantity minimum quantity of set here. So if the minimum quantity of sugar is 10, for example, if I put in 5 and random values like 43 and 23, it will show me that the inventory of sugar is below the maximum limit and inventory of wheat is above the maximum limit. I've deployed the Fetch AI agent on the Agentverse platform here. And as you can see, it gave me the input saying that the quantity of sugar is below the minimum limit 10, and also the inventory alert for wheat, where the inventory of wheat is above maximum limit of 30. So yeah, that is the whole platform. Thank you for listening.
That's very good so far. So just I wanted to know how you use the time series there.
So the data set which I found was on Kaggle. It was a ready data set wherein I got multiple lines of grocery items. It also had the number of times the item had been sold and also the date at which it was sold. So
Okay.
for unfortunately, I couldn't show you because the Streamlit interface is not that capable to load the model at a proper time. It generally takes about 15 or 20 minutes per run to generate a proper line chart to show. So the data is from 2009 to 2017, and on that data, it predicts the future 4 months of how the chart is supposed to go. And that's why I used CAD Boost because it was more efficient. I tried to use it with Light BGM, but the trading time was taking too long to load, so I just decided to go with CAD Boost.
Wonderful. That's good enough. Yeah.
Yeah, so Aryan, why it is taking 15 so means time it is so much for showing the result? Do you know about it?
So the thing is that I try to lessen the minimum number of features, but also to train the data efficiently. The data set is about 50 to 60,000 of rows. So it is trying to take a lot of time in that. And mainly, I think it's because of Streamlit interface. I tried it with Google Colab. It was running bit efficiently, but I couldn't build a proper interface to show the judge panel.
So,
So I decided to go with Streamlit in this case.
so Streamlit is good for this generative AI wala model.
Yeah,
And
yeah, sir.
for this, here you can see, I see in this deploy wala thing. So did you use this deploy through AWS or direct fetch AI?
No, sir. It was
Indirect.
direct. It was directly done, sir.
Huh? Direct.
Yes,
Uh,
yes, sir.
okay. So also you can use this chainlit. Chainlit is fast compared than Streamlit.
Okay, okay, sir. I'll
And
surely
what
check it out. I
system
wasn't aware of it.
configuration for which system you are using this Streamlit? What is your system configuration?
Sir,
RAM size?
it is i7 and it is 16 GB RAM.
Okay, so at least you can use for this Streamlit for 64 GB.
Okay, okay.
It is the
Yes,
main
sir.
reason. Okay. Mm.
Yes, yes, sir. I understand that.
Okay. So it is
Yes,
good.
sir.
Yeah.
Thanks, sir. Thank you, sir. If any questions, I can answer.
No, we
No.
don't have any. Yeah.
Thank you, Team 125. That was a wonderful presentation.
Thank you, thank you. Thanks a lot. Thank you, sir.
Thank you.
Next,
Thank you.
so we have next Team 126. They'll be joining in shortly. We're so sorry. So the team's just coming in. Okay, so there's been a delay of team 126. They'll join in later. Team 127 is entering right now. Okay.
Yeah, okay.
Joey, if we can move forward a bit fast because it will be.
Yes, they're just joining. So got it. Hi, Shreya.
Hi, good afternoon.
Yeah, you're team 127, right?
Yes.
Yeah. Hi.
Okay, you'll have 10 minutes. All the best, guys.
Okay, thank you. We switch on our video.
If you all can, yes. You can start now.
Yeah, let's check my screen is. Is my screen visible?
Yes, it is.
Hi, good afternoon, everyone. My name is Abhay Mathur, and Team TensionFlow is going to present you a solution to this problem, which basically covered two major issues, which is inventory management and timely food orders. So the way we handled the way we handled inventory management was that we used a JSON database and connected it to our agents via Flask, and we had the Flask backend that was taking input from the front end and was transferring it to the input agent, which was printing it out, and also sending it to our database agent. And in the database agent, we were processing it in a way such that so suppose the input was this search for products, then the database agent will also provide a drop down giving the different kinds of sizes that we have for the product, like 500 grams, 1 kilo, something like that. And once you select that and also the product quantities, and when you click buy, that amount will be deducted from our database, and simultaneously that information also gets sent to our manager, who is another set of or another structure of agents that we have used, which is basically an employee which takes in the queries from the user, and he has a UI of his own. Because sometimes you may want to like call the manager on the phone and order something, so he can enter his own information for the product, and he will select delivery agents from on the basis of whether they are free or not, which is something we assigned using the context.storage function in agents. So he will assign deliveries to any of these agents that are free, and then their state will be turned to delivery. And once that happens, you have to wait for a certain amount of time until they come back, and then you can assign the next product. And we've also implemented another feature, which basically the idea is that if you take a picture, or we intend to implement this into surveillance cameras in stores, where they can scan the objects that are present over there, and they are able to categorize them into the different product categories that we have, and they're able to automatically take a stock of the product the products the store has, and as soon as they're taken out of the shelf and taken out of the store, their product count goes down. And we actually used LSTM to base our we based our model on past orders, and it was a time series data. So for every month we had a certain amount of quantities for each product that we had, and based on that we intend to predict this year's amount of the quantity of each product in every month. So using this we can make the store better prepared for being always stocked enough, so that they don't run out of items quickly. And we also have a feature called an alert agent, which basically, once the stock in our database goes below a certain level, which is decided by the LSTM model that we use, it sends a notification to the store that says कि your stock is low, and it also gives you the amount by which you should restock it. And this amount is just decided by our LSTM prediction for that month. So suppose we are low in suppose our January cashew prediction was 2,000 units. So if we go below 25% of that, it'll send us a notification saying you are low in stock and you have to restock it by this much amount. And the future scope we want to implement for this is real-time route optimization, which is basically like we want to send specific products to delivery partners that are in the same route on the same locality, so we save time that way. And we've already done part of this route optimization using the delivery free state and delivering state. And we also intend to implement seamless payment gateways, market basket analysis for so that based on your previous orders, they're able to give you recommendations and promotions and stuff. And we also already do some of this analysis based on the past orders. So, like I said, the LST model caters to how many every single thing, like how many products and what category they were in, and how much category was available in a month, and how many we bought in a month. And apart from that, we also want to automate ordering of stocks from multiple suppliers to optimize cost, time, and availability. Thank you very much.
Great,
Would you
Abhay.
like to see our
Yeah.
implementation?
So I was thinking about your CNN model. So where
Yeah,
you are detecting all the objects. Okay. For
yeah,
example, just to ask you, for example, let's say there is a bottle, right?
yeah.
You will be using any model to train on the objects. So it will give you output as bottle. Whether it is a Pepsi or it's a Coke, which is in high demand, how you will know that?
So we already have. I've looked up a lot of data sets I have online. There's a website called RoboFlow that has these specific brand divided things for products. Like there was an Oreo packet, so they're all like data augmentation is done manually and trained. So data is available in abundance, and even if we are able to, even if the store is able to click pictures of, because every store will have a standard amount of objects that they have in their store. So if you click a picture and you're able to train your model on those pictures only, individual data sets, so even that will be pretty feasible.
That will not be feasible. There are many products, right? And you need to have a different set of labeler who will label all the objects, their bonding boxes and everything. So it will be a tough job, but you thought it that way. It's very great. And other question is that suppose if your prediction goes wrong for a month, let's say this month, so what will happen then?
So
So the safety net for that is we're not restocking only when there is zero stock remaining. We have a threshold value. So if it goes under that threshold value, we will restock. But in order to not overstock, we have this estimate value for the month.
Okay, that's great.
so it's like a 25% buffer that we've created.
Okay, good.
Yeah, well, so this is very good model which you develop. So this approach is in the background you are using image processing techniques. Am I right?
Yeah, for the
So
CNN model.
which data annotation tool you used for this categorization and classification? I am
Actually,
asking of annotation tool.
we picked up a pre-built data set that was already annotated from RoboFlow.
Okay.
And RoboFlow is actually a very good website for data annotating on your own if you need to do. But this is
So
the
did you use and this YOLO model?
No, we didn't use YOLO, although it was one thing that I was intending to use, but it would have taken some time to train. And by the end of the entire hackathon, we didn't have enough time to train our own model. But it's something that we intend to do in the future. YOLO training is, I've done it a lot of times before for other models. Also, YOLO is actually the best object detection model that exists in this era. So we can continue with that later.
Okay. So how you validate ki your model is good during training?
Training validation is done using the MSC error loss. So we try to reduce the loss and we get a training error. After that, we've also divided the data into a testing batch. So after that, we test on that batch. And I also tried it on my own random images, like on Google. That is not part of the data set also. And it produced a pretty good result. Some of the results I have, I can show you here. Here. It predicted stationery, milk, noodles.
So he's not. This is not trained by you, this one, right? This is an open source
No,
tool.
no, this wasn't trained by me.
Yeah, so that's what he was asking. So you use that, but it performs well, so that's good. And
Yeah.
yeah, and how you are means how you will get the feedback for the current observation that you will be having, right? Like in January, the
Yeah.
sales happen in certain way, right? And for example, let's say the model was estimating that you need to have 25% of sugar as a restocking 25% or 25% of the current inventory. And suppose due to some issues, it doesn't went in that side. So is there any feedback that you can provide to the model again so that you can retrain or something?
So actually, the LSTM model we trained on our own. The only this thing we didn't train, only the CNN model we didn't train. The LSTM model we have trained on these orders and this entire data that we received from the store and customers for the last year. So whatever you're saying with the feedback that we will take in for this month, next month, and this entire year, we will take in and then use that for training the LSTM model again for the next year. So next year we'll be able to predict more accurate outputs. And like this, the more the store keeps providing data to the LSTM model, its prediction and restocking ability will get more efficient.
Yeah, your approach is good, but there exists something called CI pipeline. Uh,
Yeah.
in which your data will be automatically appended to your trained data and it will be retrained on the set frequency time, like in a month or 2 months. So this you can thought of, but overall it's a good service. Thank you.
Yeah, that's a good idea. We can make it monthly also. There's lots of CI tools like Jenkins and stuff where we can integrate this entire thing. So the data is entered automatically and it passes through an LCM training model. So every month we'll get a better prediction instead of an entire yearly cycle, right? Okay.
Yeah, so very good, Abhay. Yeah,
Excellent.
thank you.
Okay.
Thank you.
That was a great presentation, guys.
Thank you. Should we leave?
Yeah. Thank you.
Thank you so much.
Thank you.
So the next team is team 126, the one which was before that. So I'm just letting them in.
Yeah, okay.
Okay, team 126. Can you hear us?
Good afternoon. Hello, am I audible?
Your voice is actually a bit little feeble. Can you come closer to your mic or something?
Hello, now audible?
Yeah, yeah. Judges, is he audible to you?
Not that good, but yeah, we can have.
Okay, if you can like change your microphone or
Yeah,
something,
sure.
it's very soft, or else you can continue.
Just give me a second.
Oh yeah, please be quick.
Hello, now audible?
Yeah, perfectly. You have 10 minutes and you can start with your presentation now. All the best.
Sure, thank you. Is my screen visible?
Yes, it is.
Yeah, so basically we have made grocery store inventory management, in which we have used in front end part we have used React CSS, and back end we have used structured query language, Flask, JSON, Python, Pandas, and for deep learning we have used TensorFlow and somewhat interconnection using API. So basically our solution is to manage the inventory levels, like if for particular food or drink, if that quantity is reached has reached the threshold, then it will be directly ordered from the vendor. So how we implemented, we have used two fetch AI U agents, in which one checks and returns inventory level from database, and other agent sends the quantity, and based on that prediction are made from deep learning models. This is the overview of our website. I'll directly go into our website. This is sign in page. So this is personalized dashboard, and then for suppose we want to add inventory items in that, then we can add, for example, some drinks and that MRP, item weight. So similar ways it will be added in backend and the database. And these are our predictions. Like we have used sequential type of modeling, and initially we have one hot encoded and label encoded the data set, and from that I'll show the data set. We have performed some of the EDAs as well. I'll show the features of our data set. One second. So it basically contains item identification, then its weight, then type, MRP, then profit. Profit it is making from one single item.
Yeah,
Then
that's great. So just wanted to know why you have added at item weights, because for packaged items like cold drink or something like that. So
yeah,
is that
so
is necessary?
hello.
Yeah, am I audible?
Yes, yes.
So just I was asking about the feature item weight. Why you have added as a mandatory thing? For example, cold drink, chocolates, anything like that.
So, for example, if from item weights, we can predict how much storage in our inventory is required. Like, these are future scopes as of now. Like, if it is reaching maximum capacity of our warehouse, then it may tell the
How
manager that.
Aryan will have the item weight of cold drink?
Sorry?
Aryan is the user, right? Aryan in the problem statement.
Yes, yes.
How he will know the weight of the cold drink bottle?
So it is basically from somewhat from Aryan's perspective as well as inventory management perspective.
Okay,
So,
fine. Move ahead. Yeah.
sorry?
Yeah, go ahead. Go ahead.
Yeah, so our target columns was item category drink and item category food. And the columns of outlet category, new outlet, moderate, old, we have omitted because it was not that much required. And from that we have predicted, and we were getting quite less error. MIC value was around 0.005. Mean absolute error was around 0.03, and R square value was 0.94.
Okay.
So this is how it is.
And did you consider time there? Seasonality of the data set?
Can you please repeat?
Seasonality, have you considered in your training data set, or have you thought of implementing RNN or something like that?
We have not implemented RNN, but we have implemented CNN model, but it was not performing that much well.
Why CNN?
Means we have tried like as CNN is basically mainly used for computer vision purposes, but we have tried like how it is performing. But after that, we have came with sequential type of modeling, and it was performing well.
Okay, means just a question. Why you thought of CNN? Where you wanted to implement it?
We have not means we were knowing that CNN is basically used for computer vision purposes, but just for trying like how it is performing, how it is behaving with our data set.
Okay, fine. Okay, good. Yes, that's all from my side.
Yeah, so what do you understand by this dropout? Why we are using dropout?
So basically, it drops the um, I'm not aware about it.
Okay.
Actually,
Yeah.
two of the
No problem.
other person are out right now. So
Yeah, understood. Okay, no problem. Thank you.
thank you.
Thank you so much. That was a great presentation. Okay, next we have team 129. They're just joining, so.
29 or 28?
Team 129, so. There is no 128, I think, in our panel.
So 129. Huh?
The next is
And which was the team number of the last presentation?
the one that just happened.
Yeah.
It's 127.
Okay.
No, 126. No, that was
126. Yeah, 126.
126. I'm so sorry. Yeah.
Yeah.
126 just completed and 129 is coming up. So
Okay.
The teams are taking so long time, na?
we're so sorry, sir. They're just joining in.
Yeah.
Yeah, they're coordinating with that team.
Because I will be available till this 4:30.
Okay, yes, sir. We'll try to wrap it up soon.
Yeah, sure.
Hi, Aniket. Okay, so you have 10 minutes. You can start your presentation now. All the best.
So, everyone, my name is Ankit Reddy. I'm from Team 129 Deadly Sins. So, based on the problem statement which we were given, we were told to make a deep learning model which will be integrated with future.
It's a problem statement, judges have told you. You can come directly to your solution.
So, we prepared a data set wherein we'll be having 10 features. So this is the dataset which we acquired from Kaggle. In this dataset, we have order ID, new order categories, subcategories, net sales, discount, profit, profit percentage, region, city, and total sales. So we are focusing on the total sales for this model which we created, and we are taking the only 7 features from this based on the feature dependency which we have done on our project. So the 7 features which we took were order ID, new order category, net sales, profit, profit percentage, and city. So based on this, we have first initially done a pre-processing on that. We have done a pre-processing on that, wherein we'll be converting all categorical variables into numerical variables, so that we can be able to use LSTM algorithm, which we have implemented for our code, and we have normalized all the values to a particular scale, so that processing accuracy can be easily generated. We split the data into test and train. We use select k-base and chi-square for feature classification, so that we can select the top 7 categories. We use min-max scalar to normalize and standardize the values, and label encoder to convert the categorical variables to numerical variables. The algorithm which we used was LSTM. In this, we have set the epochs to 50 units, so that we can calculate the variable losses, in which we can interpret the MSE, minimum mean square error, R square error, and MAE. So these were the model results which we acquired. The model achieved MSE of 80.34, which was pretty good compared to other cases, and R square was 0.9998, which is said to be the best as it is near to 1. So it is a strong fit for the code for the data set, and the root mean square is 8.96. These are the visualizations which we have done. This is predicted values, and it's pretty much a straight line, and these are the values which we acquired for the order ID. I'll be showing my code which we have written. This is the output which we got, and the graph. These are the epochs which we have calculated. That's all about my presentation, and we have no idea about fetch AI as of now. So we'll be taking slow steps one after the other. We'll be assigning some UI agents, U agents, as you have given us the problem statement.
That's fine. So can you please explain actual versus predicted value, the graph that is there?
Yes.
What is this?
This is one of the graph, and these are the
No, that graph that you were showing, actual versus predicted.
yes.
So what is this? Can you please explain?
So in this, we have taken this LSTM, and we have calculated the mean square error and mean absolute error. Based on the values, we have taken the total sales we predict total sales for the testing data set, and we've got this value.
So in the graph, there should be two attributes, right? One will be the ground truth, and other will be the prediction.
Yes.
For each data point. But I'm seeing a straight line. Is it perfectly aligning both the ground truth and prediction? What is this?
So that's what. So we got the R squared error, which determines the fitting of our data set to the testing data set, and that was 0.99, which was pretty close to 1. That's the reason why we got a straight line here.
Means
So
it's like overfitting, right? Your model is performing exception.
Slightly an overfitting. There is a chance of slightly overfitting, but I have tested these. I've downloaded other data sets also, so I'll be testing on them also, and it can pretty much close to my one only.
Okay, that's good. Thanks.
So what do you understand by this loss function?
Which one?
Loss function. I am asking about loss function.
So this loss function is used to calculate the mean square error, so that we'll be analyzing all the outputs for all the conditions for total sales based on the MSI which we have calculated from the loss function, and R square and MAE. We have determined the predicted total sales.
Okay. Yeah. Good. Thank you.
Thank you.
Thank you so much, Aniket. That was a lovely presentation.
Thank you.
Yeah, you can leave now. The next team we have, sir, is team 130. They're just joining in 2 minutes. Okay, hi Siddhant. Um,
Hello.
okay, can you hear me?
Yes.
Perfect. You've 10 minutes for your presentation, and
Yeah.
you can
Can
start
you please
now.
wait for my teammates to join? They'll join in just a minute.
Oh, please tell them to be quick. Also, could you tell your teammates to rename themselves as T130?
Yeah, I have told them.
Are they in yet?
They're not taking my teammates in. They're saying that they're not being admitted inside.
Give me a minute, I'll do that. They actually haven't joined the waiting room. Can you tell them to do that as fast as possible?
They are in the waiting room. They have shared their screenshots with me. Can you please check again?
Okay. Siddhant, please tell them that we can't see them in the waiting room. Do one thing. Do you have your presentation?
Uh, Part of my code is with my teammate actually, and they have shared their
We will
screenshots of.
let them in as soon as they're in the waiting room, but I think you can start if that's possible.
Uh, can you just wait 1 more minute? Actually, I decided our flow and it would break if.
Because they're in the waiting room.
Uh, they have shared actually the screenshots that.
Tell them to join again.
Can I share my screen?
For the presentation.
No, they have shared me the screenshots of them being in the waiting room.
Okay, tell them to leave and join again.
Okay.
This moment, yeah. Okay, Vikas is here. I'm sending him in. But I don't think so Satyam's here. So at least both of you all start, please.
Okay.
Vikas, can you hear us?
Yeah, yes.
Okay. You'll have 10 minutes, guys. All the best.
Okay, then I'll share my screen.
हेलो सिद्धांत कर सकता है शायद शायद
So hello, am I audible? Hello.
Yeah, we
हाँ
can hear you.
Yeah. So the problem statement demanded us to create a solution using view agents of Fetch AI, which would help in inventory management. So in inventory management, the major part of the inventory is the data. So our major goal was to utilize the data by using a proper database. So now we'll show you how our solution architecture is. Siddhant, can you please go? So here is our basically the proposed solution diagram. So what we have is a basic dashboard to show all the analytics regarding the profit, the sales, all the transactions occurring at the shop, as well as a chatbot. So now there are using U agents, we have created three different agents which would communicate with the front end via the client agent. So these three agents serve a different purpose all around. So the database update agent is the one which enters all the transactions occurring, such as even if an item is sold or whenever it is restocked, all the data entries are made into the database. Now the other one is the demand forecasting agent. So using the data present in the database, we have used an ML model so that we can forecast the demand for better inventory management, which would maximize our profits. And next is the NLP based database query agent, which is like which we use while using the chatbot. So what happens whenever a user wants to query anything like what is the amount of milk present at my shop? So the NLP based model would create a database query which would check the value of the quantity of milk present in the database and then give it as an output to the user. So it becomes very much easy to communicate with the database through the chatbot. So now Siddhant would show us a live demo of a project. Hello.
सिद्धांत
Is the screen I'm sharing right now visible?
yes yes
Yes, the
No,
screen.
wait, just a second. I'm sharing a different screen.
We can
Then
only see the screen where the presentation was there. So
PDF
just a minute. I'll just start the backend and take you there in just a second.
so till then I will explain the ML model like deep learning models and the other large language model feature सिद्धांत तेरा स्क्रीन बंद करना अगर नहीं
मेरा
स्टार्ट
हो
हो
गया
रहा है
अभी, ठीक है. Just
Which
take.
LLM model you use, guys? Which LLM model you use?
Okay, Google Palm we are using for the database query. So like I will explain in detail much once
Okay,
Siddhant show the demo.
sure, sure.
Siddhant, you can show the demo.
Okay. Is this demo visible?
Yes.
So
Yes.
as we can see, this is a basic dashboard. So the recent activity shows whatever products were sold in the given time, like around along with the timeline when they were sold. And now above we can see that there is the option to see the total revenue. As well, there are the options to sell a product or restock a product. So now Siddhant will show us by selling a product. So here is milk. Like if he sells 12 liters of milk, which is 12 quantity, and 1 liter is around 34 rupees. So yeah, so the transaction is shown here. Like it becomes updated in the database. Here it is.
So now we can see the products page. So the product page basically shows the total quantity of every product available right now and what is the cost price and selling price of each product as decided by the user. And the next is the analysis page. So the analysis page is to understand the demand of any particular product and how much quantity of each product was sold during a particular day. So it becomes easier to understand the trend through graphs. So we have used a graph to show the trend, and now we can see the chatbot over here. So the chatbot is basically like we just need to talk in a normal language with the chatbot, and it would give us outputs from the database by querying it. So Siddhant will show us an example here. So the the model is working in the background.
So the Google Palm understand the context of this sentence and runs a SQL query on the database, and the model generates the answer like the total 46 bottles or liters has been sold today.
Yeah, great.
So after this demo, like Vikas would show us how we actually achieved all of this through both the models. So here is like if any particular product becomes lower in units, like it is below the normal demand, so the chatbot also sends us a reminder to restock that product. So we can automate these messages to be achieved through WhatsApp chats or as well as emails to the user. So it becomes more easier for him to get the updates. Now Vikas would show us all of the models which we have used. Vikas?
Siddhant.
So this prompt is means flexible or fixed? How much?
No,
it
it is a
is
flexible.
flexible.
You can
It is very
use
much
any.
flexible.
Show me
Yes.
again this prompt. Show me again.
Okay.
Right.
For example, you can also calculate the profit. So we have purchase price and selling price. So if I give him prompt, what is the profit on selling 10 bottles of milk? It will first query a SQL, make a SQL query, gets the purchase price and selling price, subtract it and multiply with the quantity of milk bottle. Then it's produce the output. सिद्धांत तेरा स्क्रीन एक बार बंद करना मैं वो वाले पे बता देता हूँ
सो आपको कोई क्वेरी लाइक रन करनी तो मैं रन कर देता हूँ इफ इसमें
सिद्धांत स्क्रीन.
So your LLM model converts the natural prompt to SQL, then data will retrieve from this SQL query. Am I right?
Yes, sir.
Yes.
So for this SQL prompt, which model you used for LLM?
So we are utilizing LangChain and Google Palm. So Google Palm first
LangChain.
understand the yes. So
So in
is it my
LangChain, you are also using conversation chain or only LangChain?
No, we are using SQL conversion chain. So is
Conversation.
my screen visible?
Yes, it is.
Okay, so like as you can see, first we enter the connects the SQL database with the Google Palm model. So this is now my DB chain is the chain where I can pass the natural language prompt and it will convert the SQL query. So as an example, like list all product which I sell. So it will make a SQL query, select product name from product, and like it gives the output. Not only it's gives the like basic answer, you also proficient in calculating or multiplying, addition and subtracting tasks also. So what will the profit if I sell 23 bottles of milk? So this is a purchase selling price and this is a purchase price, and it multiplies with the quantity of bottles and gives the output.
Show me the
And
libraries
that's
which you use. Libraries.
yes, sir. And the last one, it's not only like works on the particular table, it also works with the multiple joint table. So for example, in the database, we have two tables, product and supplier ID. So if I give him prompt, look into products and give me phone number of tomato supplier. So
Hmm.
it first like checks who is the tomato supplier, gets the ID of the debt, and gives me the number of like debt user. So
Hmm.
like it's very much versatile. Okay, so connect going to the library.
Google
This is
Palm.
Google Palm.
So you are
Yes,
using
and this is
API. API of which one? Google API or Hugging
Google.
Face?
No, Google Palm official API.
Okay.
And then we are utilizing a LangChain for like making this SQL database chain.
And where you are using conversation chain?
So like LangChain has the library of SQL database chains where it utilizes the language model and convert it to like SQL query. It is
Great.
first like trained on such queries. Also, like the what's the benefit of this approach? If
Hmm.
sometime its model fail, we also can give the some few shots like how to answer an query. So like it's a robust and also it's
Understood. Yeah.
works in any case.
So
So
what is
now
the
I will
accuracy? Accuracy. What are the accuracy of these prompts?
more than 95%. So like very few prompts it gets failed, and we can correct it by giving a sample prompt. Then it also works on dead prompt also. So like with time, it achieve the accuracy of 100%.
Okay. Okay. Understood. So you are from which
Okay.
college, Vikas?
Sardar Patel Institute of Technology, Andheri.
Andheri. Okay.
Okay, so what about language model. So has the problem statement mentioned, we have to utilize deep learning models. So after researching on lot how to like forecast sales, we come across three different approach. The first one is using statistic based model where like ARIMA and seasonal ARIMA. So these are two statistic model which can use for forecasting sales. So the blue ones are the past sales of a product and the orange ones are the future forecasted like sales. So like as you can see, the accuracy of model is more than 95%. The pattern followed by the like forecast sale is also matching with the previous past sales. But this is a simple like a following pattern. What if you have a complex relation between for sales? So we also made a deep learning model. So this is a LSTM network, and these are the result of the first like single product forecasting model. So this model you can use for
Just a
forecasting.
heads up. I'm so sorry. You have 1 minute remaining.
Yeah. So this is the single product forecasting model, and the last model is a multiple product forecasting model. So if you have relation between multiple products, you can use this model. So these are the future like past sales, and orange one is our future sales. So like these how we covers deep learning, language model, like all state of art text for making a smart inventory. And also with the LangChain, one more like a useful thing of using LangChain is we can make it as a inventory manager or professional mentor for a owner. So for example, if I give a prod, if I have 50 bottles of milk now and daily sales is 30, so what is the optimal stock I should keep in inventory? So the model understand the context, and it gives me the 40 bottles of milk is the optimal stock you can use for in your inventory. So it also act as a mentor for a owner. So this is how we covers all the aspects of inventory. We support and grow and also guide an owner to like make a sustainable inventory. Okay. Any questions?
Yeah, very good, Vikas. Understand.
Yeah,
Thank
thanks,
you.
Vikas. So I was having some trouble, but just wanted to know how you are handling seasonality here.
In the forecasting model. Okay.
Yes.
So yeah. So like we have three approach. So ARIMA model is for non-seasonal data, and the seasonal ARIMA is made for handling seasonal data. So as you can see, at every year end of year, the sales grow high. So first we like take a difference of first we take a like seasonal difference of these models. Where I calculated. I am taking a sales of model and shifting it has by 12 months because I know that at the end of the year, I am getting a seasonal pattern. So I'm subtracting it and making the overall data as a stationary data. And then I'm applying my seasonal ARIMA model to accurate, like to make an accurate forecast. So after this all pre-processing steps, so like if I use ARIMA model on seasonal data, the model fails. So these are the past sales and this is the future sales. So my model fails. But if I use the seasonal ARIMA model on the seasonal pattern, I get the accurate answer, like more than 95% of accuracy.
That's great. Thank you.
And also we have the deep learning model also for learning complex patterns.
And which activation functions and model that you are using here for deep learning loop?
So for deep learning, like optimizer, we are using Adam. Wait, I will show all the for LSTM, we are using two-layer LSTM network because the data which we have generated is not very complex. It's making a pattern like seasonal pattern. I can't. Maybe.
That's fine. No need to show. We understood.
Okay, thank you.
Thank you, Team 131. That was an incredible presentation.
Thank you.
Thank you.
Thank you, sir.
Next one, Team 131 is coming. So. Hi, Sia. Hello.
Hi, good afternoon.
Good afternoon. Can you please rename yourself as one? Is your team number?
Yes, I'm extremely sorry.
That's okay.
Thought I did it.
Please 10 minutes and you can start your presentation now. All the best.
Thank you so much. So, a very good afternoon to everyone here. I am Sia Tata. I'm a second year engineering student, and I'll be explaining to you my model of an inventory manager. I have used Fetch API as mentioned, and I would just like to show you. One second, I'll just try to share my screen. So this is basically my program. I'll start with my presentation. What I understood with the problem statement was I had to create a inventory manager, but I thought I should give it like something different, something that is different for correlating a database to a query. So what I have done is I have made a system in which a user can input an image, or let's say there's somebody going through a grocery lane and there's a camera there, and the person can just simply show their phone to a camera, and the system can tell them whether the product is available or not. So I have currently used a database consisting of only single items, and the result will be shown accordingly. So these are certain tools that I have used. I have used OpenCV as I'm using images for my references, Flask for the connectivity, and yeah. So I'll just move on to my code now. I have actually made two variants of this program. One variant where I have taken a text input and I will be giving out an image output. So let's say I have currently considered my data set to be only of four kinds of apples, and this is what the data set um, basically looks like. So here, if you see, this is just the sorting of the data. I was just trying to get some formatting done, and now this is the image part, but if I go up, there is one section where I just look for an apple and it just tells me that it's available or not. One key feature of my program is that if an item is not available in the list or the data set, it automatically adds it to an order list, so that it's convenient for the grocery owner to keep a track of his inventory and restock as per the requirements. Another element that I have added to this program is a minimum value before reordering. So let's say, for example, the minimum requirement of the store is to have 50 apples, and it runs down and it goes to 49. So it will automatically give the user an alert to place an order for the same. Over here, I have put this picture as my like I'm the user and I'm going to the grocery store and I need to look for this item in the grocery store. Now I have mentioned the path of this image, and then as it exists in my data set, it will give me the name, the category, and the product image as it exists, so that there is more clarity. Now, I have also used Fetch AI mainly for communication between the for client and server communication. And however, I was unfortunately not able to successfully complete the part as the server stopped responding after a certain point of time due to some issues with my laptop. But this is the program, and this is a crux of what I was trying to achieve. Thank you.
Yeah, so suppose there is a means apple is there and some similar type of object if you have like tomato like that. So which feature vector you are means in the backend which feature vector you are using?
Are you asking me the output that it would show if that is the scenario?
Yes.
So basically, whatever actually my accuracy in the code right now is not as much, but in an ideal situation, it would show me an option between the two, and I would be able to select which one I need, because anyways, it's giving me an output of the item if it is available. So even if I get two similar items that look like the image I need, at least I will know that, okay, the thing I need is an option out of the two outputs that I got.
Okay.
Thank you.
Can you please tell me more about the CNN layer that you have there?
Sir, it's basically just to link the two paths as of now. Um, 1 second, I'll just try to open the server file for you. I've not I've mostly focused on applying the image comparison so that I can add a additional element to it. My server file is purely for the comparison between the two images. So between my entire data set and the input image.
Understood. Good enough.
Sorry?
Yeah, it's good. I understood that. Thank you.
Thank you, sir. So, shall I stop sharing?
You can stop sharing. Thank you.
Thank you so much. Thank you for your time.
Thank you, Sia. Bye-bye. So the next team coming up is 135. As just make a note. They're just coming in, so we're so sorry. Okay. Hi, Asta. Hello. Can you hear me?
Yes, I can.
Perfect. Okay. You've 10 minutes to go, and you can start your presentation now. All the best.
Okay. So two of my team members aren't here. One of. Can you check the waiting room once?
No, were they going to join?
Yes, they are. They are. Or is it fine if one presents?
If they're not already here, then you can start.
Okay, cool. One second, can you just check for Ghoshank's ID? Ghoshank was at panel 1.
Asta, we can't see the green. If you can start, please start as we're running out of time. If he comes, I'll send him as soon as possible.
Okay, sure.
Okay, he's here. He's here.
Okay.
Yeah, you all can start.
And just a second, I'm sharing my screen. Uh, share. Share. A very warm good afternoon to all the judges and panel members. We, Team Queset, are here to present our solution for the given problem statement. I'm Astha, and along with me, I have Khoshang and Rutuja as a part of our team. So the given problem statement stated that Aryan, who is the owner of a family-owned grocery store, faced issues in handling his business because of poor inventory management and untimely food orders. So we proposed a solution to develop a solution using the U agents of Fetch.ai and create a deep learning model. So the first sub part of the problem being untimely food orders. So what does come to our mind when we think of untimely food orders? There can be excess of stock or there can be shortage of stock. So two important factors that we took into account were quantity of the demand and when it was demanded. And we optimized and worked towards the ideal solution. So no shortage, no excess, and supply equals demand. Also, we divided our stock categories into four major categories: perishable, necessary foods, branded foods, and hygiene. So our logic was, suppose if there is a product X which has a particular amount of stock for n number of days, and we realized that after n number of days there was a shortage of the product. So the issue was the stock wasn't sufficient. So in the next order we have to bring we have to take into account the difference. So we defined a variable named difference is equal to stock minus demand. And if the difference turns out to be positive, then we need to order food that uh, because we do not have enough in our stock. And if it's negative, then it doesn't matter. Uh, for the second part of the problem statement, which was the sub problem, it was inventory management. Poor inventory management can happen due to irregular servicing. So our logic was for every inventory, we can assign a serial number, and each inventory will have a scale assigned to it. The value of on a scale of 1 to 10, we have to decide how efficient is the inventory working currently. And by that, we can schedule different uh, servicing time periods for each inventory. So this was a proposed solution. Uh, Thank you for listening. If you'd like, we can share our code too. Am I audible?
Yes, yes, you are audible. Yeah, so it is good. Yeah.
Uh, so just a second, I'm sharing the code.
Okay, can you please also explain more about your deep learning model?
Sure, sir. Sir, in the deep learning model, we had the system that every time the shopkeeper asks the agent to order something, to restock a particular product, then the deep learning model will take into account the previous stock that was bought, like in how many units it was bought, and also how many days back was it bought. So according to that, we can define a timed frequency, and we can change. We can check that if that frequency stays constant or is it getting affected. And according to that, we can change our frequency, and hence the frequency at which we restock our product.
Yeah, that's good. So thanks for the presentation. Thank you.
Sorry, sir, I wasn't able to hear you.
Oh yeah, I understood your problem, so it was good. Yeah, thank you.
Okay, thank you, sir.
Thank you, guys. That was a great presentation. Y'all can leave now. Thank you.
Thank you, everyone. Thank you for listening to us.
Just to know, the team just presented was 135. And the team coming up, I'll just tell you what they are.
Noted.
Okay.
Hello, sir. Satyajit here. I heard one of you guys are leaving right now.
Yeah, near 4:30.
Okay, so is there any possible way you can stay a bit longer till like 5?
No,
Because
no,
I
not
was
possible.
finished with the advanced ones, the panel
Yeah,
one.
same for me also. Means I have also some personal exigencies. I will be also leaving by 4:30.
We have only 8 presentations left, sir. So if you can, this is a special request because we have 5 o'clock talk.
Or if you can reschedule it after 6, it would be also great.
So rescheduling would be a bit difficult because all the other participants, we've told them it will be ending at 5:30.
Okay, so I will connect with my mobile only. Is it
Yes, so
okay?
that works. Yes, sir. Yes, so that would be perfect for us. You can just
Yeah,
Okay.
yeah,
And
okay.
how I can manage this results sheet?
So you can either write it down on your phone's notes app, like whatever you feel would be the best, and then you can just send that to us. You can just write it on WhatsApp to the any one of the POCs you have.
Okay, so it is manageable. Yeah.
Yes, yes, yes.
So end of the day today, I will share this whole sheet. Na?
Okay, sir,
Is it
works.
is it okay?
Yes, sir, that works for us.
Okay.
Yes, only 7 teams, sir. I'll make sure it happens like extremely quick.
Okay.
Just give me a few minutes. I'll be back.
Okay.
And we've just got like one team cannot present due to some reasons. So we just have 5 teams remaining. Hi, can you rename yourself as your name and your team number? Okay, Dilnaz and Krupali. Okay, y'all are team 138.
Yeah.
Okay, judges, that's a change. I'm so sorry. This is 138.
Okay, noted.
Okay, yeah. Y'all can start, guys. Y'all have 10 minutes. All the best.
Just a second, I'll share the PPT. Is it visible?
Yes.
Yes. Okay. Good morning. We are team 138 Void Mail. My name is Delzan Bharucha and my teammates are Krupali and Raj. And we are from RGIT College. So we are part of the advanced hackathon and we are going to be presenting our solutions here. So for the advanced problem statement, we identified two main problems. The first was poor inventory management, and the second was untimely orders. So for the poor inventory, for the untimely orders, we decided to estimate the travel time for delivery. We did this by using the Habersign function to calculate the distances between two geographical points. And we created a function to estimate the delivery time based on the distance and the average speed. So we took the average speed to be 20 kilometers per hour for any vehicles. This allows us to improve the sales as a better delivery time. The estimation will increase user satisfaction, which will in the end increase profits. For the inventory management, we use the deep learning model LSTM, that's long short-term memory, to predict the demand of when the inventory should be stocked. So the way it works is we wanted to predict what the customers might, which items the customers might want and when they will want it. And this will allow us to always have the inventory stocked for the appropriate item, which will again in turn increase profits. A main issue we faced with this was finding an appropriate data set. So we used the big basket data set that we found online to implement this. As far as the Fetch AI U agents, we used the U agents to take the orders as well as a storage agent to store the data. So one agent was used to take the orders from the front end and send it to the storage agent. The storage agent will check the stock. If it's available, it will accept the order and update the stock for the items. And then the storage agent sends the new stock data to the LSPM that predicts which items should be stocked and whether, and this is given as a 0 or a 1 for stocked or not fully stocked. So this is a flowchart that we created to explain our process. So the way the input is taken is the item is inputted as a tuple, where the first element is a string, which includes the item name, and the second element is an integer, which includes the quantity of the item. So in this example, it's potato 3 kgs and onions 4 kgs. This is sent to the user agent to take the order. Here, using tuple unpacking, the agent checks if the item stock is equal to 0. If it is, then the order is not placed. But if it is not, then the order is placed and it updates the stock. This backend agent is used for this, for carrying out this process, and then sends the new updated data from the storage to the LSPN model, which takes in the updated stock information and outputs advice accordingly on whether it should be stocked or not.
That's wonderful. So just a question, how you are handling the quantity of potatoes and quantity of cold drink?
So we have used the U agent to store all this data for the quantity and the item. So it's an item and then the quantity after it.
Quantity means here count and there means in kgs. So how you are handling that? Isn't bias that you are going to add to the model where you are having potato?
Sorry, can you repeat?
So how you are handling kgs and count in same column or as a
Yes.
different?
So for this, we assume that the kg, it's not a very good assumption, but we assume that the kg and the count is the same. So
Okay.
3 kgs of potato, or like, for example, if there's shampoo, it will be one item of shampoo.
Yeah, that's the point that you need to consider in future. Yeah, but that's a good thing. Yeah.
Yeah. So we just like to say at the end that this was our first hackathon, and we are aware that the final project is far from what we imagined it to be. A lot of our time actually went into finding the data set and figuring out how to use the fetch AI agents because we never used it before. But it was a great experience, and we'd like to thank the judges, coordinators, and MMIMS for the opportunity. Any more questions?
No, we are good actually. So yeah, thanks for joining.
Okay. Yeah. Thank you.
That was a lovely presentation. Thank you, guys. The next team is joining shortly. So,
Okay.
hi, Krupali, you all can leave now. Hi, Aman.
Hello.
Hello. You'll have 10 minutes. Are all your team members here?
Yeah.
Perfect. Wait, you're only two of y'all? Or you're a
Yeah, like one of us has an exam tomorrow, so both of us will be presenting.
Perfect, perfect. Okay, you'll have 10 minutes to go. All the best.
Thank you.
Judges, this is team 141.
Am I allowed to share my screen?
Yeah.
Okay.
So, greetings panel. I am Aman Mehra and this is David Gandhi. And our team Enemies of Syntax is going to present you our view of the given problem statement at hand. So firstly, we started with identifying the problem statement and understanding the need of a historical data set of how we're going to apply, on which we are going to apply our model. So we've gone and created our own data set using Python and random module for a certain 7 types of groceries that could be sold at a local grocery store. We've done this so that we can get the timestamp nature and the inventory input and output to make sure that we have an appropriate data set so that we can apply our deep learning model. When it comes to deep learning, we've gone with the LSTM model using RNN to predict the actual sales of the entire inventory over the 30 days period from the data set. So we've actually applied the model together and made inferences on all the products sale. And then particularly, we've even applied the model and shown our visualized our predictions for each and every single item in the inventory. Then we've also analyzed the data set thoroughly while we've worked upon the turnover, understanding the turnover of the items, categorizing the best selling items and the worst selling items, which could also help in manual decision making, which we'll highlight how we've incorporated that later. So moving on to the next slide. So we've worked upon a simple interface, considering the nature of our person at hand, that is Aryan, and being an underprivileged guy. So we've made sure that our user interface is very simple and to the point. So now my teammate Dhavit will be explaining the website part of things.
So we've actually divided the first page firstly into two sections with two graphs in each section. So the first one will be the top three, the best selling items and the worst selling items simultaneously, as you can see. I'm sorry. And on the first page itself, we are supposed to show the orders, which will be automated by Fetch AI. But for some reason and time constraints, we are not able to show it here. And on the left, we have a sidebar with which we can navigate through the website. So moving on to the next page. This is the inventories page where we'll have two drop downs, one for the category and one another drop down for all the stuff inside that particular category. So like if Aryan chooses to view fruits and veggies and clicks bananas, this is the model that he'll be shown with, or the graph showing the actual sales that he had in the previous month and our predicted sales. So using this, he can track each and every product that he has in his inventory. And below you can see suppliers like Fetch AI will definitely use one supplier on its own without any manual requirement. But if Aryan wants to filter it out, like if he has a certain need of urgency, so he can go with the premium food supplier who's delivering within 3 days. Or if he's laid back, if he doesn't have any issues with time constraints, he can go with the cheaper one like one thumb suppliers. Next, we are showing the complete data of the sales that he has made in a month. So as you can see, the green spikes are the actual sales, the blue are the trained predictions, and the red are the tested predictions. So using this, he'll get a pretty good idea of how he's been doing in the entire month. And here is by each item, how much each item has scored for him and how well has it been going for him in the entire month. And we have buttons like check inventory and track individual products by which he can surf through this website on his own when and if required.
So moving on to our use case with the Fetch AI is supposed to be using Fetch AI to automate and connecting with our deep learning model and automating our process of buying the stock from the suppliers. For further upscaling, what we could have done is eventually, since after a point, our Aryan shop would be making profit. So we could even incorporate Fetch AI to connect multiple of his shops so that the accuracy of the AI and the promptness of ordering would improve. And if Aryan needs to, in India, like generally we have communities of people working in similar professions as well. So for his other fellow mates with their different grocery shops, even they could be connected using Fetch AI, and we could even add a specific login page so that this could be scaled up to different users so that all of them could be connected through Fetch AI and our prediction could be much better and understanding of the model could even improve. So the tech stack that we've used is we've used Keras, TensorFlow, Scikit-learn, and for making the website, we've gone with basic HTML, JavaScript, and Bootstrap, and obviously Fetch AI. Further enhancements. So what we've understood is, firstly, the main problem was that our amount of data set we feel was still less because we need a more robust data set with much more values, which we could take so that our deep learning models accuracy could improve and adding on more features that could be available. Then to improve further upon this, see currently like for example, if I say that in news that tomatoes farming has stopped for some reason due to rain or something. So then this could be directly affecting the prices of tomatoes at Aryan's shop. And he would probably want to upload tomatoes in his shop as much as he can so that he can sell those tomatoes at a premium price and increase upon his profits. So we could use NLP to integrate this and make it more so that we can classify news and take all the relevant news and make a difference with that. And then further taking into account, since there are seasonal fruits and vegetables, when we're talking about mangoes, for example, so their demand would be very high in certain periods of time. So that probably the inventory needs to constantly filled up to the top so that he can keep selling and make sure he gets more profits during that season. And furthermore, like in India, we believe that there are a lot of festivities and each festivity offers its own requirements. So certain spices for certain dishes or probably like for events and everything. So for that, there might be an unusual change in the data set, unusual change in the purchasing pattern as well. So we believe that we could even further take account of that also. Now, when it comes to adding on features, we believe that we could have taken another suppliers data set that could be in real time comparing the prices of the three different suppliers as we showed earlier and like multiple different suppliers in fact so that if Aryan wants to order one particular, for example, quality. So we could have these factors to make our prediction using a different ML model as well, connecting with again Fetch AI. So that even if we want, then Fetch AI could do that, automate that process for him as well. Then our lastly, what we could change is taking into account of more fresh produce, considering vegetables are a big part of local grocery shops. So that and their shelf life so that we could understand that which veggies have a long shelf life so we could have them ordered much previously but the ones which have a short shelf life we would have to require to pay more frequent purchases in smaller quantities. So these are the few changes that we've identified and on this note like we would like to end our presentation upon on how we would have gone with the problem statement at hand. Thank you.
Yeah, if you can tell me more about the NLP part where you are categorizing the topic modeling or doing something similar.
So when I'm talking about that, what I mean is, like there we can use first categorizing all sets of news on the data using an ML model, and then understanding, making inferences of what kind of news is going on regarding groceries. Because there are sometimes, like for example, Maggie was historically, the first thing I can remember is Maggie. It is such a big part of our Indian grocery stores. But at one point, there was something detected in lead, and it was all over the news. So that is something which is negative. So so then we can use NLP to understand what kind of news it is, and
That is for exceptional cases, right? It's not valid for all the product
yeah, so then
all the time, right?
considering, see, what we thought was that because Aryan is ideally underprivileged and his business has not been doing well, so then we thought that even if, like, how much ever we can refine a procedure for him so that he can, be ready for even exceptional cases, so that he can make minimal losses initially and try to gain upon more return on capital and increase on profits. And for example, then considering we can even use social media, for example, currently plays a lot of a big part. And there are food influencers in particular. So, for example, if there is a specific trend of, I would say, like avocados and their benefits, and there's a news article and it's trending on Instagram also, then we can understand the sentiment analysis and make sure that it suggests that we can order a new type of, for example, a vegetable, that we can order avocados. So that could also be helpful for Aryan to capitalize on the new trends as well.
Yeah, thanks. Then we don't have any question. Yeah.
Thank you, sir. Thank you so much for your time.
Thank you.
Yeah, thank you.
Thank you, guys. That was an incredible presentation. I can leave now. Thank you. So I've just put up a last call message. We'll see if there's any other team showing up. Or
Okay,
else,
and what was the team number of this team?
this team was team 141, sir.
Okay, thanks. Thank you. Yeah.
Okay, with that, we've completed almost all of our teams, so we would like to thank each and every one of you for participating in our hackathon. The event was enhanced by your passion and coding skills, making an incredible success. Deep gratitude to everyone for staying engaged throughout. We appreciate your commitment and we hope you enjoyed the 18-hour coding marathon. We really appreciate the valuable contribution of our distinguished judges who do not only provided the knowledge, but also helped to shape the hackathon with their evaluations. Your commitment and time have been crucial in transforming this event into a genuine showcase of creativity and brilliance. Thank you for being a vital part of it, sir.
Thanks, Joey, for being there and supporting us. Thanks a lot.
Thank you, sir. Uh, just a tiny question, sir. You'll have updated the grading sheet, right?
Yeah, almost all of the means scores are there in the sheet, but few are in there my notebook.